Okay, so this is the last topic, section 1.4, and it's talking about inverse of a relation. So all you're doing is usually your points are x, y, and now you're switching them so they're y, x. So in this first picture, I have drawing on there, but if you were to record all the points in a table, these are the points. So the inverse is just when you switch your y's with x and x with y's. Okay, so your original domain, this is as low as your picture went, or as far left. This is as far right. So this was the domain. Your x had to be greater than or equal to -6 and less than 6. And your range is from 0, and the highest it goes is 6. So it has to be greater than 6 but less than, or greater than 0 but less than 6. And so when you have the inverse, those domains and range switch. So it says determine whether the relation and its inverses are functions. So if something's a function, the x's do not repeat. So in this case, the original, so since the x's do not repeat in the first picture, then it is a function. So now if we look at the inverse, we have 2 6's as x's. So this one is not a function. Okay, also you can draw a line, so you can use, on the original picture, you can use the vertical line test. If my picture only gets hit once by a vertical line, or in one spot, then it's a function. But if I was to draw a horizontal line on the picture, and it hits more than once, see here, it hits lots of times, then the inverse would not be a function. So that is the horizontal line test. Example 2 says, consider the function x squared minus 2. So I drew the picture right there. Graph the inverse. So here's the inverse. Describe how the domain could be restricted so that the inverse would be a function. So if you look at the original, it is a function because the x's don't repeat, but if you look at this one, it's not a function because it hits in this spot and this spot, and our x's repeat. And so if we were to eliminate half of this graph, say y had to be greater than or equal to 0, so you only had this part of the graph, then that would make it still a function. And then the last way is how to find the inverse when you have an equation. So I just switched my f of x to a y. And then you swap out your y and your x. So I replaced my y with x and my x with y. And then you solve to get y by itself. Okay, and you do the same thing for question B.